Oh boy. I didn't know I was going to be following machine learning and Street Fighter 2. That is tall order. All right. Hello, everyone. I'm going to be talking about having your cake and eating it too with this delicious recipe of GraphQL and Reason. As Bruce mentioned, Sean Grove, coming out of San Francisco. I work at a company called OneGraph. I'll use it today, but I won't talk about it too much. My background, I've been in lots of startups, ran engineering for a payments company, and my background typically was in ClojureScript. I added source map support to the ClojureScript compiler, but these days I work mostly in Reason and Rust. Cool. So we'll just dive in, what to cover. I'll start off the talk. Before going into GraphQL, let's talk about REST. REST is really cool. Raise your hand if you have never used any RESty API. I don't think a single hand has gone up, right? The experience is huge in the industry. Everyone has encountered a REST API somewhere. And that means that there are just so many great frameworks for building REST APIs, right? Django and Rails will just do so much for you. And it also means that not only are server-side infrastructure robust for REST types of services, but there's also SaaS things like Cloudflare and Fastly that will help just tremendously with your APIs. So I would say that if there's any technology that is going to overlap with Rust, it has a lot of ground that it needs to cover in order to actually be compelling and useful in some way. And let's actually take a look at the Spotify REST API. And I want to use Spotify because I actually think that the REST API is really well done. It's really nicely documented, and it's quite beautiful. So let's see. This is the Spotify API. You can see it's broken out into nice sections. I can see, like, maybe I want to see, for example, the player API. I can jump down there. And I see that there's these different endpoints and how to hit it. Maybe the headers or the query parameters that are required there. And even get this kind of nice, like, example JSON response. I mean, maybe pretty printing would be nice, but overall, it's pretty nice, right? It's very impressive. They've obviously put a lot of work into it. But now let's propose a hypothetical. Let's say, for example, we were building a Node client, and we wanted to wrap the Spotify API in a nice way, make it a little bit more idiomatic maybe for JavaScript developers. How would we know, for example, as we were implementing this Node wrapper, if we had covered all of the different endpoints inside of Spotify's API? How would we know all of the different parameters, and maybe bring that documentation inside of our Node client to help with the developer experience? It would be pretty tough, I think. I mean, we could, these are nice, documents. We could maybe scrape the HTML, could find all the headers for each section, use that as a description. We see the verb over here and the endpoint. And, we could figure out the query parameters, the type, whether or not it's required. So we could figure this out. But it's probably going to be a lot of work. Whatever result we get, we'll probably have some typos. There'll probably be some HTML that might get mixed up in there that we didn't quite scrape exactly right. So we'll have to massage it a little bit. And then we'll have a nice Node API. Maybe we have something like some JSON document that's describing all the endpoints and whatnot. And we can use that as our test to make sure that we're covering everything. Unfortunately, I think that even if we've done all of that work, it ends up being pretty hard because Spotify, as kind as they are, they're probably not going to reach out and tell us that, hey, we've updated the API in some way. So that means that keeping up to date with them is going to be a process, right? That we probably want to try to figure out how to automate that. Every time we update it, we probably have to run our scraping. We have to figure out how to get that description out. And ultimately, what this comes down to is the fact that this computer assistance is one way only, right? Although there are frameworks that help you in lots and nice ways, they only go one way. They help you build that API. And if they're really nice, maybe they help you generate some documentation about that API. But from the client's point of view, there's nothing, like the computer can't help us at all. This is impenetrable to a computer, right? This is meant for humans. So, with that in mind, I want to talk about approach GraphQL from the point of view of introspectability, of computer-assisted reasoning. And that is to say that computer introspection is fundamental to GraphQL. It cannot exist without it. Before I talk about that real quick, though, I want to just give a quick crash course on GraphQL. Maybe show of hands, who has not used GraphQL in production? Who has never heard of GraphQL? All right, cool. And then who has maybe used it in like a pet project, a side project or something? Okay, so we'll just do this real quick. So GraphQL has 3 parts at the top level. There's query, mutation, and subscription. Query is your way of reaching into an API and reading data out of it, right? You might want to read about the current user, get their email, their ID. You might want to get a list of posts and their titles, that kind of thing. Mutations are your rights. They're your effects. So this would be something like sign in, create a post, destroy a post. And what's going to happen is it will run that effect, and then it will return you a node from which you can do read-only access. So for example, having created a post, maybe it returns to you that created post, and then you can query in and get all the related data. And then subscription, we won't really talk about today, but it's for like queries that might change. As far as the syntax goes, you can see here we have 2 operations, and you can have multiple operations in one document. We have a query, which is that read-only part, and we're going to reach into user, and we're going to pull out the user's ID and email. Similarly, underneath here, this server has implemented a mutation called setEmail. I don't know exactly what it does, but I see that it takes a new email, so maybe it's like updating the currently logged in user's email. And having then updated that user, it's going to return the user back to me. And in this case, I'm going to get ID and email again, and also updated at. And you can see that the type that is returned is the same between the 2 of them. But I'm able to select different fields based off of what I need at that given moment. So it gives me, the client, much more ability to kind of slice and dice the data as appropriate for me. So now, let's say that we have that query document, which is just a string, ultimately. To actually send it to a server, we're going to package it up into a little JSON blob with a couple of keys, most important one here being query. And then you have some variables and some operation names, if you want. So with that, we can make a query. So let's say, for example, we had a wrapper around the NPM API. NPM is very kind to share lots of their data. And you can see here that with this query, I want to reach into NPM. I want to get some information on a package with a name called Express. I don't know, it's an up-and-coming thing. Probably not many of you have used Express yet, but you should try it. Mark my words. And then, having gotten that package, I have some fields I want to select. I want to get the name of the package, and maybe I want the downloads, last month, the total count. So we're going to curl against the server, and then we're going to send our document. And I'm going to jump into here. And I'll throw that into JQ. You can see that I was able to query into NPM with that simple curl. And it looks like Express has something like, I don't know, 2 or 3 downloads per month, looks like. So you can see like it's pretty powerful what we're able to do here. But the cool thing is, with GraphQL servers, back to the introspectability thing, you can not only query data from an API, but you can query data about an API. So every server, GraphQL server, implements this schema field. And the schema field describes all of the things that this GraphQL server knows about. So for example, in this case, what I'm saying is, hey, I have a query. I want to read some data from you. I want to read data about you. I want you to give me a list of all of the types that exist as a server. And I want to know the name about it. So we can just take this, and we'll do the similar thing. So we'll throw this in, and we'll get just the top 150 different types inside of there. So really, really trivial to just see, hey, what are the types? OK, so we can also hit that not only from curl, but obviously just from the browser. So you can imagine in this case, we're going to do the same exact thing where we have this introspection query, and we're going to pull out some types. And I'm going to just assign the result to window.result. So we'll throw this in. And now if I ask for window.result, you can see it's this data object, so just like we saw in the terminal. You can see we have all these different types in here. And maybe what I want to do is modify this a little bit. So I'm going to get not just name, but we'll say description. I want to know, like, what's the human description of that type? And then what I want to do is take the result, and I'm going to filter it and say, for all of the types in here, only give me the types where the name starts with Spotify. I want a full list of them. So I can expand this, And I get like this pretty nice description where I see, hey, Spotify has lots of different things. There's search arg and whatnot. I'm going to modify the query one more time, where I'm going to say, if it's an object, right? If this is a type, it might be a string, might be a Boolean, might be an object. Well, I want to know about its fields. And for each of those fields, I want to know about the name and the description of that field. So run that. We'll do the same filtering. And now we have these objects where, we have lots more data about it. So maybe I want to look at like the Spotify album. And I see that it's a Spotify album. It has these fields. An album has ID and image and label. And you can see that like I can start to really enumerate, like, hey, tell me about yourself, server. Like, I want to get to know you. Tell me about this Spotify albums thing. So I can introspect and really start to build up cool tooling. So the important thing here is that this is an API that can describe itself to other computers, right? Whereas with the Spotify documentation, as a human, I have to work really hard to recover the computer's ability to read about it. With GraphQL, this is just natural. So you can imagine, you could build some pretty cool tooling on top of this. So there's this tool called Graphical. And this is standard. You can point this at any different API, any different GraphQL API. And let's say, for example, we want to do the npm thing again. I can just go through here, and each step along the way, I can ask. So let's do query. I can ask, for example, package. And I want to know the name. So let's say GraphQL. I want to know maybe the downloads last day. And we'll do the total count. So we can run that. And you can see I get like this nice autocomplete. I can hover over it, and I see the type of each field. If I want, I can introspect and say, hey, what's this downloads things about? I can kind of explore. If I know somewhere inside of here that maybe there's like an author, I can search the entire API in one place, and I see all these different places where there's a field or a doctrine that mentions author. But for me, by far, my favorite way to explore an API now is via this Graphical Explorer. Because we can build up a list of all of the types, we can build some really crazy tooling. So this is going to list all those top-level types. And you can imagine this is just based off of that JSON we saw beforehand. So I see there's Spotify. And I see all the things available here. I see search. And I'm going to search for maybe You and I by Dash Berlin. And I want to get the results from that. So if there are any tracks that match this, I want to get the ID and the name of it. I'll go ahead and run this. And there we go. I was able to actually explore the Spotify API without almost, well, I had to type the song name. But other than that, I was able to explore the API with no real typing, which is just a phenomenal way of doing things. It's by far my favorite way of exploring an API. And not only exploring, but this can be used in so many different ways. You can imagine, for example, that you are responsible for shipping a GraphQL API. Because we can just introspect and say, give me the current schema that you have. And that's just JSON, right? Let's say the next time you push, I'm going to also ask, give me the schema for this current version. And then I can compare the two, and I can do a diff. I can see, did you remove any fields? Did you change a type? Did you do something that might break a client out there who already lies on this? And it's so trivial. It's standard, because we know exactly the structure, and we can interrogate and introspect the server. So in this case, every time we push to CI, it takes the current production schema and the schema we're about to produce, and it fails the build if we break a schema. If we are going to break a client, it won't work. We just won't allow it. And if you think about how difficult this would be to do in an automated, scalable way for REST, it's incredible. Not only that, but you can also take those differences in schema over time and generate something like this. This is GitHub's GraphQL schema changelog. And you can see kind of every time they push what has happened. So this enum value has been added. They added some union members. They added some fields, or they're saying that this is going to be removed. And this is a really nice set of documentation to see how this has changed over time. And GitHub gets this for free, right? This is just a matter of taking those different schema versions and using that data to generate really nice documentation for humans. And not only that, but because we know the types of every field, it makes mocking really easy, right? Let's say, for example, that the server team says, here's the schema that we're going to implement. We haven't implemented it yet, but this is, we promise, what it's going to be. As a front-end developer, you can just start hitting a fake version of that and just have it generate fake strings. fake IDs, fake emails. And you can just build as though this were the real data. And then once the server comes and actually implements it, you know it's going to connect exactly as it is. And if the server hasn't implemented it appropriately, then you will know immediately what the difference is, right? We can use that diff tool. And I think you can actually take this even further. You could imagine, for example, if you are running a service with an API, you could actually do an analysis of every field, the data inside of every field, and say, what does this look like? Right? A little bit of machine learning, as we just saw, and do a classification. And say, this field always looks like it's an email. So whenever I generate dummy data, I'm not going to generate just a hello world string. I'm going to generate an email. This field looks like it's always a first name. This one looks like it's a full name. And so you can actually start to generate really, really authentic data without even having to have the user sign up. So you could imagine someone just hitting your API and experimenting with it with fake data, entirely fake data, but one that looks very realistic. So they can get a really good sense of what your API is like. And I do want to give a caveat here. REST can kind of do some of this. For those of you who are familiar with Swagger or OpenAPI, it is an attempt to make it so that a computer can read about an API's implementation. The challenge here, in my experience, has been that typically these are best effort. It's really hard to keep them up to date. You know, there are lies, there are damn lies, and then there's documentation about APIs. And OpenAPI kind of is somewhere between the second and the third one of those two. Not only that, but GraphQL has these other really nice properties. So REST really struggles in many cases with over and under fetching and multiple round trips. So let's take another example, which is the GitHub REST API. GitHub has moved to GraphQL for its latest API, but it still supports REST version. And their REST, again, they do a really good job with their API. It's really well designed. It's very powerful. So this is an endpoint where I can get information about a repository. And if you notice, it has a little bit of data in here, just in case you had some questions about a repository. I think we're almost, no, wait, almost, okay, yeah. So you can see a little bit of data about a repository. GitHub is very open with sharing lots of data. But there's a challenge here. Like, why is there so much data? And it's because it's one endpoint, and I don't know, as a server, what fields you actually rely on. So I better send you everything. And not only that, but the problem is, if I send you something and it doesn't include the field you have, you might have to make another separate request. Right? Let's say, for example, you were getting some information about a repository, and then you wanted to know something about the author. Should I maybe also include information about the author just in that first response, just in case? That way I can speed up your use case. And so you end up with either underfetching, where you don't have the data you need and you have to make another trip, or overfetching, where you can see if you're not using all of these fields, you pay a huge price in terms of the data that you're actually forced to download. And this is a really big deal for different clients. And so I think the really cool thing you can do here is, let's go ahead and make another query. So we can say, for example, the GraphQL equivalent of this would say, I want to go into GitHub. I want to pull out a repository. I want to know its ID. Maybe I want to know about its name. In this case, you know what? Let's go into issues. I'll get the first 10 issues. For each of those issues, I want to get the ID and the title and maybe the state. So go ahead and run that. And you can see I was able to get out lots and lots of very specific data for me in one single request with no back and forth, no overfetching, no underfetching, in just a couple hundred milliseconds. And so if you imagine like the equivalent amount of data that is downloaded through here, that was potentially tremendous amounts of data saved. And not only that, but the server can actually analyze what fields have you as a client accessed. Let's imagine, for example, you're implementing an API, and it turns out there's a bug in one of the endpoints. Right? Maybe the ID field is actually mal-generated in some cases. And what you'd like to do is reach out to the clients who have been affected by this. If it's REST and you sent it out to everyone, you don't know who actually just got it by accident and who has actually stored it in their database and might act on it in some way. So what you have to do is kind of send out an email, spam everyone, and say, hey, just in case you stored one of these IDs, you should probably purge it and refetch. However, because we know exactly the fields in GraphQL, you just keep a little note somewhere about who has access to this field, and then maybe send them a personalized email, and in a way that is much nicer and doesn't scare and spam everyone. And this can be taken pretty far. So let's say, for example, I want to do something like, so there's this YouTube video, or YouTube channel called Numberphile. It's a fun channel. What I'm going to do is use this API to pull out some information about a YouTube video. And given its ID, I want to pull out the snippet, and I'll pull out the title. So go ahead and run that. I'll log into YouTube real quick. OK, and maybe I want to do something like, let's see. YouTube video, we do snippet, and then upload channel. So what I can do is go through here, and I want to go from the title of the video, and I can also get the channel ID, as we saw beforehand. But maybe I just want to like hop over to the channel and get the title of the channel. So we'll get the title of the channel. And the cool thing is, on YouTube, you can actually associate your channel with external media, things like Instagram or Twitter. So for every Twitter account that this channel is associated with, I want to hop over to Twitter and pull out the first 5 tweets. For each of those tweets, I'll pull out the text. And I'll pull out the entities. And now we're in the Twitter part of the graph. And Twitter has this idea of entities. So this would be something like user mentions. For each of those first 5 tweets, any user who's mentioned, I want to pull out their screen name. And let's go ahead and recur. And I want to pull out their first 5 tweets. And for each of those tweets, I'll pull out the text. And I think we all know the obvious thing to do here, having gone from a YouTube video over to the channel, over to the Twitter, to anyone who is mentioned, is if anyone at the edge tweeted about a video, then I think we have to hop back into YouTube and then pull out maybe the snippet. So we'll get the title and maybe the statistics on how many view counts this has. So go ahead and run this. And I need to log into Twitter now. So I'm going to authorize this. Come on, Twitter. And they're not kidding. This may take a few moments. All right, one more time. Come on, Twitter. OK, there we go. So go ahead and run this. And you can see we're going to make 30 or 40 API calls across these 2 different services, mesh it all back together in about 1.2 seconds. We made 11 calls, and we got all this data. So we can see, for example, view count. There we go. So someone over here tweeted about Peaceable Kings with 145,000 views. So this is like pretty extreme, right? Where one client can express their needs across lots and lots of different services and mesh it together with only one API request in the eyes of the client. OK. And again, some caveats. REST can, in some ways, technically do this. The original thesis for REST has some ideas around here. But raise your hand if you have ever used a REST API which allowed you to do this and you understood how to do it. I don't see any. This is one of the things where REST is potentially capable of doing, and people will tell you, hey, REST can do that. But I've never seen a REST API that actually implements it. And then to end off on this introspection idea, not only is the server-side stuff actually introspectable, the queries themselves are introspectable. So what we can do is, for example, use the AST Explorer here. So there's a query, and it has been parsed. And I can look at the AST, and you can see maybe I want to get the name of this query. It's get user. Or if I say, like, my user, you can see it just updates there. And I can see the selection set, so I can see all the fields that it's selecting. And so you can imagine from the server side, we can easily analyze the queries themselves. Or from the client, maybe inside of the editor, we want to know all the fields and whatnot. And you can build some pretty cool tooling. In fact, if we combine the ability to introspect servers and the ability to introspect queries, how far could we go? So let's go ahead and take this again as an example. What I'm going to do is make a mutation in Spotify. What it's going to do is pause my player. Having paused the player, it will return the new version to me, and I want to know whether or not it's playing and the progress. Add another mutation here. Spotify, I want to resume the player. I'm going to do the same thing. Is playing in the progress. one more. I want to know Spotify, and I want to know next track. And because this is next, I want to know maybe the item that's playing. So I'm going to get the ID and the name, whether or not it's playing, and the progress. And I'm going to go ahead and name this pause, resume, and next. OK, so we were able to inspect the server. But now let's inspect the query. And what we can do here is you can see that it's actually analyzed these individual mutations and generated a whole React application that we can just copy and paste. And we can do some pretty cool things here, where a lot of people don't know that you can actually name a mutation. So this is valid, but you notice here that we give it a name. And we say, hey, when we analyze your query, we notice that you're not conforming to all the best practices. You might want to do this. We won't block you, but we can kind of gently guide you to doing the right things. So I'm going to go ahead and rename this back to pause. You can see it updates immediately. I'm going to copy this. I'm going to go into Code Sandbox. I'm going to paste this in and save. And let me open up my player. And now I'm going to go ahead and let's do side by side. Right now it's paused. I'm going to go ahead and resume. Oops. There we go. So, and then I'll pause it. And I'll do next. And next. And I have a fully working Spotify player that I was able to click my way through, copy and paste, and have an interactive React application. I knew I had to do something after that machine learning talk. Ugh. All right, cool. So with that thing I was able to do, clicking through, copy and paste, again, really good documentation on Spotify's API. But like, what would it take to do the equivalent of that level of tooling for REST's API or Spotify's API? Like, I honestly just have no idea. I don't even know how you would approach it. It's just so difficult. And one last caveat, I just want to end on this for GraphQL, is that GraphQL is not SQL. They share a suffix, but GraphQL is sufficiently or significantly less expressive and less powerful than SQL. It's intentionally so, and so I just don't believe all of the hype about how expressive it is. It is very expressive. It's just not a silver bullet. Cool. So let's get into the second part of the talk, which is Reason. So JavaScript is cool. Lots of industrial experience. It's everywhere. Frameworks, blah, blah, blah. Any new technology. Got a lot of ground to cover. However, JavaScript is not without its challenges. Let's take this function. This function is nice. It's called insert customer. It takes a few arguments, name, subname, org. And the challenge is, just looking at that, I don't know what those should be. I don't know the types. I don't know really what this does, especially org. Org for me is a challenge. Because insert customer maybe says something like it's going to do something with a database. And so maybe org is like an org ID. Or maybe it's an object with like an ID field. And so just looking at the outside of this, it's really difficult to figure out what it is. I'm going to have to read the body of this function to understand what it does. And if you have several dozen of these in a stack trace, and you're trying to debug something, that means you have to dive into the body of a lot of functions before you're going to be happy. So I'm going to approach this from the point of view of TypeScript, because TypeScript helps out a lot here. TypeScript, however, is, while it's, I think, a masterpiece in many ways, it has some really significant challenges. TypeScript tries to take JavaScript, which is an immensely powerful language, and it tries to recover some safety. Right? It tries to figure out like what kind of guarantees can it give you that there aren't going to be bugs. And this takes a lot of very clever people working very hard, writing a lot of master theses about how to do this. Reason, on the other hand, starts from a sound, small language and only adds features if it can guarantee certain performance guarantees and certain correctness guarantees. And so you can kind of imagine that Reason grows outward, and TypeScript tries to provide safety from the outside in. And because of that, that means that Reason kind of has grown over the years to have the equivalent of something like Immutable.js built in. This is just its standard library. That's how you work with things. It has things like Lambda and functional programming just as part of its standard library. ESLint and strict null checking, things like exhaustive switches and reachability, which are pretty difficult to get inside of TypeScript, are just there inside of Reason. And all of that is built in, plus you get crazy things like a built-in preprocessor, which is like Babel, has been there from the beginning. You have a sound type system. Oh, and the compilation targets are so cool. So Reason is about 25 years old, so a little bit older than JavaScript. And it has had a lot of academic investment, a lot of smart people writing a lot of theses. And what that has meant is that OCaml and Reason now are able to compile to so many different targets. So you can write Reason and compile to run on the web, but that same Reason code can potentially run and compile to a single x86 binary. It can run on your Raspberry Pi with native ARM64, and even things like light bulbs, which is the EPS32. The ARM64 target means that you can take your Reason code and compile to native mobile platforms. So no JavaScript core or anything. This is running straight on the mobile platforms. In addition, it can go to lots of places that I think people in here will be familiar with. So serverless. Antonio Montero did a demo last month running on the AWS Lambda and Zeit platforms. And the way this works is you get a single binary that gets uploaded to the serverless platform. And it will boot in under 10 milliseconds. It is incredibly fast. And for an initial like hello world processing time, it is sub-millisecond. It is 1 millisecond. You still get charged for more than that, but still 1 millisecond. And you can take this idea even further to unikernels with OCaml, where your application will actually compile and run without an operating system. It will run directly on the hypervisor, so no Linux, no nothing. It's incredible. And then one last thing about Reason is that it has a very, very careful attention to developer experience. It has gone so far as to adopt as much of the JavaScript syntax as possible to look as familiar as possible. If something looks different, it's because it must look different. There must be a reason for it. Otherwise, like, we should make it look the same. And right now, the domain that Reason really excels in is for making web UIs. It has built-in syntax for JSX. It has a great Reason React story. It can interrupt with all the NPM libraries, so you can do an incremental migration, or you can still use all of the JavaScript libraries you'd like. And in fact, Reason was created by the creator of React, Jordan Walk. He originally prototyped React in SML, and Reason is his way of saying, I want this language to match the properties of Reason, so they really work well together. So let's take a quick comparison of what it actually looks like between React and Reason. So on the right here, I have the new React hooks version, and it's using a user reducer hook. And it's just, you know, a really simple component with some buttons. And on the left, I have the equivalent Reason React. And you can see that actually they're about the same in terms of lines of code. I think the Reason React is a little bit bigger. And I have a little bit of additional like typing I have to do here. I have to tell it the type of the state, and I have to list all of the actions. But what I get in return, like for this pretty small addition, is pretty amazing. Because now this is entirely type-safe. I am guaranteed that there will never be a runtime error with the equivalent of the Reason React one. So for example, if I forget, for example, to mention click, as soon as I hit save, it tells me, hey, your action, your reducer, doesn't handle everything. This is guaranteed. If this action is dispatched at runtime, this will crash, and I won't compile. Not only that, but it can go the other way around. Or let's say I want to add a default case. So this is just how you say catch all. And no matter what the action is, I'm just going to return the current state. I get another error saying, hey, this match case is unused. So down here it's telling me this is not used. You can go ahead and remove it. And the reason this is important is these actions might not be listed right next to this component. And so often, what happens is whenever you're doing a refactor and you have a list of your actions or any sort of variant, you kind of like, you remove it and you think, but I'm not totally sure who uses this, right? So you have like a switch case and you're switching over all the possibilities. You're not totally sure. And so you think, all right, well, I probably need to go ahead and like leave it in there just in case. And Reason's going to tell you, hey, listen, I got it. I checked. I checked everywhere in the code base as soon as you hit save, and I know that you don't need this. You're safe. So, like pretty low overhead. And I want to give a caveat. There are definitely challenges in typed languages. Especially when you're new to them, it can be difficult to know how to express certain things. So like I said, Jordan created React originally in SML and came up against a problem where he couldn't figure out how to make the type system happy. And so then he translated it into JavaScript and went from there. The other thing is some programs are actually valid enough where you don't care about all of the edge cases. And you just want to go ahead and move forward with it. And that can be hard to represent. But let's say that we're OK with those challenges. What could we do? What if we combined GraphQL's introspection, the Babel-like preprocessor, and this slick type-safe Reason React thing? I think you get something like this, where what I have here is a GraphQL, a Reason React component. I'm using GraphQL. This is like a GQL tag. And I have this query that's parameterized by an optional string called email. And as soon as I make this required by adding a bang afterward, and I hit save, it's immediately an error. Because I didn't provide it with this. I made it required. And it immediately tells me what's wrong with it. And then once that result comes back from the server, once the response can be in lots of different states. There might be loading, it might be an error, or there might be data. If you used Apollo, this is typically where you see if data.loading, if data.error, and it's easy to forget that. In this case, Reason is going to say, no, you have to handle these cases. What do you want to display for these different cases? And then as I go through, I can ask at any step along the way, hey, what's the type of this thing? And if I have a typo, for example, maybe I thought it was name instead of full name, as soon as I hit save, it's going to say, hey, there isn't a name thing here. Did you mean full name? And I get autocomplete. I can autocomplete from the server into my editor all the way across. It's fantastic. I'll do one last demo. So hot reloading. How hot is hot reloading? So this is a JavaScript application running over here. I'm going to use a library called reprocessing. So this is reprocessing. You can build video games in it. And it cross-compiles to the web, to iOS, to Android. And this is running natively in an OpenGL. And you can see here, I'm going to change this gravity constant to 80. And as soon as I hit save, you can see it floats kind of nicely there. And I'm going to change it to maybe 800, and it'll fall down and crash. And what I'm going to do here is just add one character to my JavaScript application and hit save. I'm going to come over here and change this for a little bit, and I change it a little bit more. And I think this one is almost loaded up. It's so fast. It actually Reason is compiling native binary, hot swapping it inside of memory, keeping the state in tens of milliseconds. It is a phenomenal experience. So in summary, Reason I would say is fast, it's fun, practical, and thoughtful. So in summary, what do we get whenever we combine all of this stuff? From GraphQL, we get incredibly powerful clients where we can get exactly the data we need, no overfetching, no underfetching. We get incredibly reduced latency and much, much better developer experience. From Reason, we get very, very safe clients where if the server can't satisfy a query, it won't compile. If you try to access a field that the server doesn't have, that's an error. Any null field, you're forced to check. That means no more runtime errors from the server sending you bogus data. And luckily, this is one of the few cases where it is both better in terms of security, performance, and correctness, and also easier to do. So with that, let's see. I'll skip over the back end. I'll just say limitations at the end here. Both GraphQL and Reason are still figuring things out, right? Like I said, REST has had a long time to build out the infrastructure in the industry. But what you see today is usable. It's great. The front end doesn't implement all of the spec, but every time I've gone through it, it has implemented more and more. So now we're down to just a few different things missing. And there's actually an open source application. I haven't updated to the latest Reason React, but this is a Spotify DJ player. And if you go there, it will log in with Spotify. It'll read from your player what you're currently playing and give you a link to share to someone. And it will then control their player and synchronize it with yours. So whatever you're listening to, you get to play DJ for other people. And it uses Reason React, GraphQL, and WebRTC to communicate entirely serverlessly. So take a look. It's a lot of fun. And with that, thank you very much.